Welcome to clickmyproject.com. Let we discuss about the process automated detection of driver fatigue based on entropy and complexity measures. Let me see the abstract of the process. Electroencephalogram is a recording of the electrical activity of the brain from brain waves produced by the electrical current passing through the nerves during the brain activities. The classification of the EEG signals can be helpful in monitoring patients and identification of different brain activities. The EEG signals were classified based on the statistical features obtained from different segments of the EEG signals. The EEG signals were segmented with the help of Hilbert-Wang transformation. The segmented signals were then classified using neural network classifier. The neural network is a pattern recognition tool that identifies the type of signals by analyzing the patterns of the features extracted. Epileptic fatigue occurs intermittently and unpredictably. Mindless epileptic fatigue detection in EEG cassettes is highly required. In our method, HHD-based time frequency representation has been considered as the time frequency image. The segmentation of the time frequency image has been effected based on the frequency bands of the rhythms of EEG signals. The histogram of gray sub-images has been denoted. STFT is unavoidable in trade-off between time and regularity firmness. The wavelet theory is limited by the fundamental uncertainty principle. The struggle of WVD is the severe cross-term as indicated by the existence of negative power of some frequency assortments. The identification of the fatigue based on the features extracted is more efficient compared to the other feature extraction methods employed for the analysis of the signal. The overall performances were measured in terms of the performances of the neural network classification methodology. Let me see the flow of the process. The input EEG signal were taken. Since we implement the process in a simulation environment, the dataset of EEG signals were used. The dataset containing some EEG signals were taken for this process. EEG signals were taken. After that, HHD transformation is applied to the EEG signal. The transformation transforms the original signal levels into different regions, and based on that, segmentation is employed. Different frequency levels in the EEG signals were segmented. After the segmentation of the EEG signals, features were extracted from the signals, which is based on entropy, kurtosis, standard deviation, mean. Like that, the extracted features were then given as input for the neural network classification methodologies. The overall performances were estimated based on the features. For the neural network classification, the trained feature labels and the extracted test signal features were passed, and the neural network classifies the signal as if it is fatigue or normal. So in this process, the neural network is an analysis of the sequence of patterns of the original data. So neural network usually analyze the data and find the patterns identified in the sequences of data that we have given. So here in our process, the data refers to the trained features extracted from the images. After the extraction of the trained features, the neural network is trained in order to identify different patterns in them. The different patterns in the for the identification of the different patterns in the features, labels were also helpful. The labels refers to the setting of the two fatigue and the non-fatigue signals for all the training samples that we have given. So based on those, the classification is employed, that is the signals to which it maximum correlates is identified, and if it is fatigue signal means then the result will be displayed as fatigue, else means the input signal is a normal signal. Finally, the performance of the process is measured with the help of the performances matrices. Thus, we analyze the EEG signal into fatigue or normal. Let me see the running procedure of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the user interface for the execution of the process. This interface contains buttons and display accesses for the execution of the process. Select any one of the EEG signal which is present in the dataset. This process is a trained process, and hence this process will be accurate for the signals that is provided in the datasets alone. So we select any one of the signals, and after that HHD transformations were employed. So in the HHD transformations, the images were divided into some 9 regions. The signals is divided into some 9 regions, which is helpful in the analysis of the parameters in each of the cases. After that, the segmentation of the signal is employed. The segmentation refers to the identification of particular frequency elements in the signals. So here we are extracting the gamma, beta, alpha, theta and delta segments from the input EEG signal. After that, the features were extracted from the EEG signal, which is based on the statistical parameters calculated from the signal. The extracted features will be the input for the classification process. We have calculated the process of classification and segmentation for the EEG signals obtained from the databases. After that, the optimization process is employed. After optimization, the classification is employed based on neural network classification. So the signal is classified using neural network as, and the extracted classification methodologies is compared with the support vector machine. Finally, the analysis of the process is done, and the analysis shows that overall performances of the process. The obtained performances indicates that the process is much more efficient compared to the other existing methodologies for the classification of the signals. Thus, we have calculated the features for the EEG signals based on statistical parameters, and also we have identified the fatigue signals based on the patterns recognized using neural network classification methodologies.